Giselle Pico Buntilaw. My task is all about set and defining set. What is set? Well-defined finite or infinite collection of things, objects, or ideas. Finite is a countable number of elements, and infinite is not possible to count of elements. Order has no significance and multiplicity is generally also ignored. Members of set are often referred to as elements, and the notation symbol of A is used to denote them. If an object X is the element of set A, we write X, symbol of A. If the object Z is not an element of set A, we write Z, symbol of E, A. The number of elements is the finite set is denoted by N and A. The study of set and their properties is object of set theory. For example, the item you wear, hat and shoes, socks, hat and shirt, pants, and so on. This is known as a set. Other example is type of fingers, index, middle, ring, and pinky. So it is just things grouped together with a certain property in common. Next is notational. There is a fairly simple notation for set. We simply list its elements or members separated by a comma and then put some curly brackets around the whole thing. Example: 3, 6, and 9 ... that is, and the number that we called elements, and that the 3 dots means goes on forever. Elements or members mean the same thing. This is notation for the two previous examples: sock, shoes, watches, and shirts. The 3 dots called ellipses. The means continue on infinity. 2 index, middle, ring, and pinky. Sock, shoes, watch, and shirt, that is infinite set. And index, middle, ring, pinky, what we call finite set. Example of set of letters: A, B, C, ... and X, Y, G is a finite set, and EB, EBC, ... is a infinite set. Symbol used to separate on set includes that symbol, which means an or intersection, and U, which means or union. The symbol of that is used to denote the set containing number of elements, no elements, called the empty set. The curly brackets are sometimes called set brackets or braces. Defining set. As a set is well defined if there is no ambiguity as to whether or not an object belongs to it. A set is defined so that we can always tell what is and what is not member of a set. Listing of elements. Example, B 2, 4, 6, and 10. Example, X A, B, C, and A. Number 2, describing elements. This is read as C is the set of elements X such as X is an integer greater than -3. Next is numerical set. Numerical sets of even numbers, -4, -2, 0, 2, 4, set of odd number, -3, -1, 1, and 3, set of prime number, 2, 3, 5, 7, 11, and 13, and also 17, positive multiples of 3 that are less than 10, 3, 6, 9, that is less than 10.
Good day everyone, I am Reina Rose Albetti. I am the one who will discuss the properties of sets, finite sets, and infinite sets. What is finite sets? Finite sets are sets having a finite or countable number of elements. It is also known as countable sets as the elements present in them can be counted. In the finite sets, the process of counting elements comes to an end. Starting and ending elements are present in the set. For example, the set of vowels in English alphabet. Set A is equals to open bracket A, E, I, O, U close bracket is a finite set as the elements of the set are countable. What is infinite set? Infinite set can be understood as a set that is not finite. It is not possible to count the elements of an infinite set. The elements are endless or not countable. If any set is endless from start or end or both sides having continuity, then we can say that set is infinite. For example, W is equals to open bracket 0, 1, 2, 3, close bracket. This example is a set of whole numbers is an infinite set as the elements are not countable. Another example, Z is equals to open bracket -2, -1, 0, 1, 2, It is a set of all integers is an infinite set as the elements are not countable. The elements of an infinite set are represented by dots as the dots represent the infinity of the set. It cannot be represented in roster form. Finite and infinite sets are totally different from each other. The finite set is countable and contains a finite number of elements. The set which is not finite is known as the infinite set. The number of the elements present is in an infinite set is not countable and extends up to infinity. What is a null set or empty set? An empty set is a set that has no elements and can be represented as close and open bracket or null set. For example, P equals to close and open parentheses or null set. The set P is an empty set. As we discussed above, the finite set has a countable number of elements. The empty set has 0 elements, so it is having a finite number of elements with no continuity. So, an empty set is a finite set with a cardinality of 0. What is set equality? When young maths enthusiasts dive into sets for the first time, they often ask, what is set equality? Set equality is the term that is used to indicate that two sets are equal. Any two sets, finite or infinite, are equal if they contain the same element. Consider two sets A and B. These two sets are only equal if and only if each element of set A also exists in set B. The order of the two sets elements does not matter as long as elements are the same. Let's consider the following two sets A and B to understand this statement. A is equals to open bracket 1, 2, 3, 4 close bracket. B equals to open bracket 2, 4, 1, 3 close bracket. By observing the two sets A and B, it is evident that although the two sets A and B are different, they contain the same element. Another factor to consider while analyzing the set equality is that the two equal sets also have the same set size, equal cardinality. Hence, as long as the two sets have the same elements and equal cardinality, they will be classified as equal sets. What is subsets? Subsets are a part of one of the mathematical concepts called sets. A set is a collection of objects or elements grouped in the curly braces such as A, B, C, D. Set A is said to be a subset of set B if all the elements of set A are also present in set B. In the other words, set A is contained inside set B. Example, find all the subset of set A equals to 1, 2, 3, 4. Solution, given A equals to 1, 2, 3, 4. Subsets is equal to empty sets 1, 2, 3, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 1, 2, 3, 2, 3, 4, 1, 3, 4, 1, 2, 4, 1, 2, 3, 4. What is a universal set? A universal set is a set which contains all the elements or subjects of the other sets, including its own elements. It is usually denoted by the symbol U. Suppose set A consists of all even numbers such that A is equals to 2, 4, 6, 8, 10, and set B consists of all odd numbers such that B equals to 1, 3, 5, 7, 9, dot, dot. The universal set U consists of all natural numbers such that U equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, dot, dot. Therefore, as we know, all the even and odd numbers are a part of natural numbers. Therefore, set U has all the elements of set A and B, set B. There is no formula to find the universal set. We just have to represent all the elements in a single, which is collectively called a universal set. Example, let us say there are three sets named as A, B, and C. The elements of all set A and B and C is defined as A equals 1, 3, 6, 8. B equals 2, 3, 4, 5. C equals 5, 8. Find the universal set for all the three sets A, B, and C. By that definition, we know that universal set includes all the elements of the given set. Therefore, universal set for sets A, B, and C will be U equal 1, 2, 3, 4, 5, 6, 7, 8, 9. From the above example, we can say that the elements of set A, B, and C are altogether available in universal set U. Also, if you observe, no elements in the universal set are repeated and all the elements are unique.
Good day everyone, I am Kimberly Bakuli and I am the one who discuss about Venn-Euler diagram. As you can see in this picture, it indicates a Venn diagram. What is Venn-Euler diagram? Euler diagram is a picture that represents sets and their relationships. Consists of closed curves, the elements of which are represented by the interior of the curves. The relationships to be represented are overlap, containment, or neither. That's the Euler diagram. Next is the Venn diagram. Venn diagram represents all possible overlap permutations between sets. Venn diagrams are a subset of Euler diagrams, for they are the Euler diagrams that represent all potential overlaps whether the sets have elements in common or not. Venn diagram is a visual depiction of the similarities and differences between two or more different items. It consists of a series of shapes, usually circles whose edges overlap, but it's not required that you use a circle. It's probably the most convenient shape because several circles can overlap easily. Next is drawing Venn diagram. Determine the relationships between the sets such as subsets and intersections. First, draw X within Y if all members of X belongs to Y, or X subset of Y, or X union of Y equals Y, or X intersection of Y equals X, or NX intersection of Y equals NX. Second, draw X overlap Y if some members of X belongs to Y, or X intersection of Y an equal empty set, or NX intersection of Y an equal of 0. Third, draw disjoint sets X and Y if no members of X belongs to Y, or X intersection of Y equals empty set, or NX intersection of Y equals 0. And here are the illustrative examples. Number 1. Draw a Venn diagram to represent the relationship between the sets X equals 1, 3, 5 and Y equals 1, 2, 3, 4, and 5. Solution. Since X is a subset of Y, step 1. Draw a circle X within the circle Y. Here is the circle of X and this is the circle of Y. Step 2. Write down the elements in circle X. 1, 3, and 5 are the elements of X. Step 3. Write down the remaining elements in circle Y. 2 and 4 are the remaining elements in Y. Number 2. Draw a Venn diagram to represent the following set universal equals 1, 2, 3, 4, 5, 6, 7, 8, and 9. X equals 1, 2, 5, 6, Y equals 3 and 9. Solution. Step 1. Draw a rectangle and label it U to represent the universal set. And here is the rectangle U that represent universal set. Step 2. Draw circles within the rectangle to represent the other set. Label the circles and write the relevant elements in each circle. This is the circle of X and circle of Y. 3 and 9 are the elements of Y. 1, 2, 5, and 6 are the elements of X. Step 3. Write the remaining elements outside the circle but within the rectangle. 4, 8, and 7 are the remaining elements inside the rectangle. Thank you.
Good day everyone, I'm Gretchen Susana Balignet. I will be the one to discuss about the complement of a set, intersection of two sets, and intersection of three sets. So, complement of a set. The complement of set A denoted by A prime is the set of all elements in the universal set that are not in A. The number of elements of A and the number of elements of A prime make up the total number of elements in universal set. So, the complement of set is the set that includes all the elements of the universal set that are not present in the given set. Okay, example. So, the universal set are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. A 1, 2, 3, 4, 5, 6. B 0, 4, 8, 12, 14. So how to get the complement of A? So as I've said, complement of set A contains the elements present in universal set but not in set A. So all of the numbers that are in the universal set and not in set A will be the complement of A. So the complement of A are 0, 7, 8, 9, 10, 11, 12, 13, 14. All of these are present in universal set but not in set A. Complement of B. 1, 2, 3, 5, 7, 9, 10, 11, 13. Again, all of these are present in universal set but not in set B. Okay, next is the intersection of two sets. The intersection of two sets, X and Y, is the set of elements that are common to both set X and set Y. It is denoted by X intersection Y. So the common element of the set will be the intersection of two sets. Okay, example. The elements of set A are 1, 2, 6, 9, 10, 15. While the elements of B are 3, 6, 9, 12, 15, 18, 21, 24, and 27. So now we will gonna find the intersection of A and B. So C is the set of intersection of A and B. So the element of this set will be all the common elements of set A and set B. So the common elements of set A and set B that will be our set C, the intersection of A and B are 6, 9, 12, and 15. All of these elements are both common in set A and set B. So now let's proceed to the Venn diagram. So here's the Venn diagram. So let's assume that the left side of the Venn diagram is the set A and the right side of the Venn diagram is the set B. And set C will be at the center, our intersection of A and B. So here it is. So next is the intersection of three sets. The intersection of three sets, X, Y, and Z. It is denoted by X intersection Y intersection Z. It is the set of elements that are common to sets X, Y, and Z. So here's the example. The elements of X are 1, 2, 3, 4, 5, 6, and 7. And the elements of Y are 1, 3, 4, 6, 7, 10, 11. The elements of Z are 3, 5, 6, 10, 11, 12, and 13. So first is, we will find the X intersection of Y. So we need to find all the common elements of X and Y to be our X intersection of Y. So the X intersection of Y are 1, 3, 4, 6. These are all the common elements that X and Y both have. So next is, we will find the intersection of Y and the Z. So again, the common elements of Y and Z. So the common elements of Y and Z are 3, 6, and 7. These are all the common elements of Y and Z. Next is, we need to find the tree set. So from the topic itself, the intersection of three sets. So the three sets are X, Y, and Z. We need to find the X intersection Y intersection Z. So all we need to do is to find the common elements of X and Y and Z. So you can see all the common elements of X, Y, and Z are 3 and 6. Yes, 3 and 6 are the elements of X intersection Y intersection Z. Lastly, I will show you the Venn diagram. So that's it.
Good day everyone, I am Krisha Gay Lumayag Alpad and I'm the one to discuss about the complement of the intersection of sets. The complement of set X intersection to Y is the set of elements that are members of the universal set union, but not members of X intersection to Y. It is denoted by open and closed parentheses X intersection to Y. For example, suppose union is equals to set of positive integers less than 10 and X is equals to open bracket 1, 2, 5, 6, 7, close bracket, and y is equals to open bracket 1, 3, 4, 5, 6, 8, close bracket. Then after that, draw a Venn diagram to illustrate open and close parentheses x intersection to y. Then find open and close parentheses x intersection to y. Solution. A. First, fill in the elements for x intersection to y is equals to open bracket 1, 5, 6. Fill in the other elements for x and y and for union. Shade the region outside x intersection to y to indicate open and close parentheses x intersection to y. So this is the Venn diagram in the complement of the intersection of sets. Union x and y. So the shaded region indicates open parentheses x intersection to y apostrophe. So we can see from the Venn diagram that open parentheses x intersection to y is equals to open bracket 2, 3, 4, 7, 8, 9 close bracket, or we find that x intersection to y is equals to open bracket 1, 5, 6 close bracket, and so open parentheses x intersection to y close parentheses is equals to open bracket 2, 3, 4, 7, 8, 9 and close bracket. Union of sets. The union of two sets A and B is the set of elements which is A or in B or in both. It is denoted by A, U, B, or it say that A union B apostrophe. So example, given union is equals to open bracket 1, 2, 3, 4, 5, 6, 7, 8, 10 close bracket, and x is equals to open bracket 1, 2, 6, 7 close bracket, and y is equals to open bracket 1, 3, 4, 5, 8 close bracket. Then find x union y and draw a Venn diagram to illustrate x union y. So the solution, x union y is equals to open bracket 1, 2, 3, 4, 5, 6, 7, 8 close bracket. So the solution given is only written once. So this is the Venn diagram of union sets. Union x and y, then number 1 up to 10. So the shaded region indicates x union y. If x is subset to y, then x union y is equals to y. Another example, given union is equals to open bracket 1, 2, 3, 4, 5, 6, 7, 8, 10 close bracket, and x is equals to open bracket 1, 6, 9 close bracket, and y is equals to open bracket 1, 3, 5, 6, 8, 9 close bracket. Then after that, find x union y and draw a Venn diagram to illustrate x union y. So this is the solution. X union y is equals to open bracket 1, 3, 5, 6, 8, 9 close bracket. Another Venn diagram of union sets, or another example. So this is, since x subset to y, therefore x union y is equals to y. The complement of the set x union y is the set of elements that are members of the universal set union. Combined operations. Combined operations involve the intersection, union, and complement of sets. perform the operations within bracket first, or other operations are performed from left to right. So, for example, given that union GHP list of elements A, B, C, D, union is equals to open bracket x 1 s x s 10 is an integer, close bracket, A, G intersection to H union to P. G is equals to open bracket x is a prime number, close bracket. B, open parenthesis, G intersection to P, apostrophe union to H. H is equals to open bracket x is an even number, close bracket. C, H apostrophe intersection open parenthesis G union to P, close parenthesis. P is equals to open bracket 1, 2, 3, 4, 5, close bracket, and D is open parenthesis P union to H union to G, close parenthesis, apostrophe intersection open parenthesis G intersection to H, close bracket. So here are the solution. G is equals to open bracket 2, 3, 5, 7, and H is equals to open bracket 2, 4, 6, 8, 10, close bracket. A, G intersection to H union to P is equals to open bracket 2, close bracket, union to P, and this is the G intersection to H is equals to open bracket 2, close bracket, and the result is open bracket 1, 2, 3, 4, 5, close bracket. B, open parenthesis G intersection to P, close bracket, apostrophe union to H is equals to open bracket 2, 3, 5, close bracket, union to H. The result is open bracket 2, 3, 4, 5, 6, 8, 10, close bracket. C, H apostrophe intersection to open parenthesis G union to P, close parenthesis, is equals to H apostrophe intersection to open bracket 1, 2, 3, 4, 5, 7 is close bracket. The result is open bracket 1, 3, 5, 7, close bracket. D, open parenthesis P union to H union to G, close parenthesis, apostrophe intersection to open parenthesis G intersection to H, close parenthesis, is equals to open bracket 9, close bracket, intersection to open parenthesis G intersection to H, and close parenthesis. The result is open bracket 9, close bracket, intersection to open bracket to close bracket is equals to set